So let's keep talking about this triangular coupler. So we're going to use general extrusion. And in order to do this extrusion, you need to define the cross-section area, and also you need to define the length, which is the thickness in this case. So the thickness is T, that's straightforward, but how to create a triangle like this? So what we need to do is we first need to, in order to define this cross-section area, we actually need to give MATLAB the coordinate of these 3 points. So in order to make our life easier, we want to make sure this A, B, they are along the x-axis. And then in that case, our P is actually underneath this x-axis. The location of this P point is actually, so x-coordinate is AP times cosine delta. And then the y point is AP times sine theta. So the theta angle is here. So if you click OK, update, then that's the triangle we're going to form. And then again, we can change the color. And then we can use yellow and then update it again. Click apply and OK. So in this case, you need to remember that the coordinate is located at A point. So that means we can directly connect this solid to point A. But we need to connect this B point to joint B. So that means we have to shift the coordinate by that much, which is the AB length, or L3, before connecting to B. So that's why we have to do another rigid transform. And then drag it in. And then the length of this transform is along x-axis. And then the length is L3. Because the origin is at A point, we have to shift the entire length to reach the point P. And then what we do is connect here and then connect here. So now we have everything. So we can define the input for this joint O2. What you do is double click, go to the actuation, change the torque to calculate it automatically, change the motion to input, and then click apply. And now you can see one more port that allows us to assign the input. And then we want a ramp, and then you can search ramp, and then we can drag this ramp function here. And then the slope of the ramp is 31 degrees per second. That makes sure that after 10 seconds we got a full cycle. And then this cannot be directly connected to your model because it's a Simscape function. So we have to use this converter before connecting to O2. Okay, we have to assign a degree, assign a unit to this function. And the unit is not radian, it's degree, so we have to use DEG here. And we also have to change the input handling, change from 0 derivatives to filter input, and then we need to use second order filtering. Apply, okay. So the other thing you might want to do is go to the gear part, go to the model configuration parameters, and then double click, and then go to software details, change the relative tolerance to 1E -9. In this way, we can actually increase the resolution of your simulation. So we can click run, and then a window pop up, and then we want to change the top view. Then you can see how this triangular coupler is moving right now. Okay, cool. So, but then we want to find the trace of this point P. How to do it? So, as we mentioned before, in order to measure the position, what we need is actually another transform with a transform sensor. Where is it? Okay. Let's say or we can directly find it in the Simscape multi-body and then frames. That's the transform sensor. So we want to measure this position. So this position is relative to the ground, and we want to measure it at point P. But then we need to first tell the Simscape where that point P is. So we have to go to this solid. In order to reach this point P, we have to make a transform this coordinate system along the AP line. Okay, so we need a rigid transform, and this transform should be able to transfer us from point A to point B to point P. Sorry, so we use Cartesian transformation, and then along x direction we want to transfer AP times cosine delta, and then along y direction we want to transform AP times sine delta. So we connect one end to this solid. That means right now the output of this follower is the point P, and then we want to connect it to the sensor. And then we want to sensing the position of this point. So go to translation. We want x and we want y. So now we have x and y. So what you can do is you can go to library again and then go to Simulink, and you find a signal routing, and you want to merge these two signals. But before doing that, you have to convert the Simscape signal to a Simulink signal, just using the other PS to Simulink converter, and then convert it here. So right now the output of this thing has two coordinate informations. If you want to see the plot, you just connect these to an XY graph. You can find it here in the sync, and then XY graph. Oh, actually in XY graph you don't need these to merge the signal. So okay, let's directly connect it to this XY plot, and then click run. So where is it? You cannot see anything in your XY plot. That's because your XY plot is from -1 to 1, and actually your figures is actually your trace is in some place in here. So we want to increase the scope of this XY. You just double click XY graph and make sure this window is wide enough to cover everything. And then from 0, 0, all the way to 10, 10. So we got a much wider view right now. You can double click and then click run again. In this way, you can see that trace of P. If you want to zoom in, then you can zoom into 0 to 4, and then Y to 4, and then click apply, and then run it again. In this way, you get a better view of that trace. Okay? So that's everything you need to learn for example 4. Hopefully you will enjoy it.